Hello, this is FlippedHarber for Algebra 2. In this video we'll cover Section 2-3, Graphing Linear Functions. The objectives for this lesson is to determine whether a function is linear. We also want to know how to graph a linear function given 2 points, a table, an equation, or a point and a slope. The topics for this lesson include linear functions, slope, the x and y intercepts, and the slope-intercept form of a line. The outline for this video is determining linearity, is something linear, point and slope, x and y intercepts, vertical and horizontal lines, the slope-intercept form, and how to graph. Now, to determine if a set of data is linear, we take that set of data, and if there is a constant change in x values and a constant change in y values, then the data is linear. So in our data here, the time data is going to be our x, and it goes up by 1 every single time. The distance from land will be our y value, and it goes down by 25 every single time. Since both the x and the y change at a constant rate, then yes, it's linear. So, what do you think about this data? Are either of these linear? Well, we can see a constant change in the x of adding 2 in data A, a constant change in y of adding 3. Data B, we have the constant change in x, but we don't have a constant change in the y values. So data A is linear, but data B is not. Now, looking at a point and a slope, we want to graph the line that goes through the point 1, 1 and has a slope that's equal to 2/3. Now, I want to remind you that that slope, given in fraction form, the top number is how far we move up, and the bottom number is how far we move to the left or right. When both numbers are positive, we go up and to the right. If one number is negative, we go down and to the right, or up and to the left. So, we start by marking the point 1, 1. We apply our slope up 2, right 3, and we mark another point. And we can keep on going up 2 and right 3 and mark a couple more points if it's going to make the graphing easier. Now, let's graph the line that goes through the point -2, 3 and has a slope that's equal to -1/3. Again, one number is negative. Don't make them both negative. So we'll mark the point -2, 3, and we either go down and right, or we go up and left, making sure that only one of those numbers is in the negative direction. Our x and y intercepts are handy when drawing a graph. A lot of times we can find our x and y intercepts very quickly, and it's 2 nice points to mark in order to draw the line that goes through them. Our x-intercept is where the graph goes through the x-axis. Our y-intercept is where the graph goes through the y-axis. So let's find the x and y intercepts of this line and graph it. Now, this line is given to us in what's referred to as general form. Our x and y terms are on the same side of the equation, and it equals some number. So in order to find our y-intercept, we plug 0 in for y, and that whole term goes away. -3 times 0 is 0. We solve for the x, and we get x equals 6. So our x-intercept, that is where the line crosses the x-axis, is at 6. In order to find the y-intercept, we do just the opposite. We plug 0 in for x, and we solve for the y. So we find out that our y-intercept is -4. Now, that wasn't too difficult to find, and now we have 2 points to mark on our graph, and we draw the straight line through them. So here's our graph. Let's talk about vertical and horizontal lines. When a line is vertical, that is that its slope is undefined, we have to use an equation x equals some number in order to describe that vertical line. When a line is horizontal, that is its slope is 0, we use an equation y equals some number to describe that horizontal line. Let's talk about slope-intercept form. This is our quote-unquote standard form that we use in algebra. It allows us to easily spot the slope and the y-intercept, which is a good starting point for when we want to graph. So our slope is right in front of the x. If we don't see anything in front of the x, it's what we refer to as an understood 1. Our y-intercept is that number at the end, that plus b. Again, if we don't see that, it's an understood value, but that time it's 0. So let's graph this equation by putting it into slope-intercept form. All we need to do is move the 3x over by subtracting it. So we get y equals negative 3x plus 5. We mark our y-intercept, which is the 5, and we apply our slope. Now when we have a whole number slope, we just make the whole number the rise, and our run is 1 unit. So from our y-intercept of 5, we go down 3 and right 1, mark that point, and then we draw the straight line through them. Alright, that's it for this lesson. You've got your homework. It's time to get started on that, and I'll see you in class and I'll see you online.